welcome to another video of A-Level-Up Maths. So, to analyse kind of experimental data and a kind of more, this kind of overlaps a little bit with how you would use kind of some rules of logs in line with sort of science. So, eyes here that are covered. So our first one is a y equals some number a times x to the power of n. So if you've got this kind of relationship, your graph is going to be a curve. When you analyse the data, it's kind of quite hard to draw a curve of best fit to data. It's much easier to draw a straight line of best fit. Okay, so what we'll do is we will apply a specific set of steps in order to then be able to plot some data, draw a straight line of best fit, and then take readings from that graph to work out what our value of A is and what our value of N is for our actual relationship between. Just looking at this, if we plot log y on the y-axis, then our y-intercept will be log A. Our gradient will be n. So need to have log x plotted on the x-axis. So let's see what happens when we do that to the following here. Well, first what we need to do is add two more rows, that of log x and of log y, and we need to complete those. Okay, so what I've done is I've plotted on this axis, the y-axis, I've plotted log of y, and on this axis I have plotted log of x. You can see these 5 points here line up in a straight line, doing a line of best fit. You can see, reading off here, we get 0.53, and like we said, our y-axis intercept was log of A. So this means that log of A is equal to 0.53. Remember, this log is actually a base 10, so our opposite is 10 to the power of, which means our A value is going to be 10 to the power of 0.53, which is 3.39 to 2 decimal places. And up here, we also said the gradient will be n, measuring our gradient on here. So overall we can say that A is 3.39, our gradient is 1.4, which is n, which means our final trend is y equals 3.39 multiplied by x to the power of 1.4, and this is our equation that connects x and y together in this particular series of data. Let's have a quick look at case 2. This is slightly different because this is y equals a times b to the power of x, or x is the power on this one. We can see that various things here, like log a is going to be our y-intercept. We're going to plot x against log y, and we can see that log b is going to be our gradient. So what I've done here is I've calculated log y for this series of data in our second example. I've then plotted x against log y, so I've plotted, for instance, 2, 2.096, and then 3 and 2.628, etc. I plotted the 5 points you can see here. And now what we can do is say our y-intercept is equal to 1, and our y-intercept is log a. So log a equals 1, so a equals 10 to the power of 1, which is 10. And looking at our gradient again, doing the same calculation to work out the gradient. So as our gradient is log b equals 0.532, b equals 10 to the power of 0.532, and that comes to 3.4. So our relationship is, as we now know what A and B are, we can write it as y equals, looking at this, y equals A multiplied by B to the power of x. And this is our equation that connects x and y together. So I hope that's been helpful, and I hope you enjoyed the video. If you did, then please like, comment and subscribe. And if you've got the Edexcel book, then have a look at exercise 14G to get some practice of this in. See you on the next one.